Good afternoon. Let's get started. So thanks to Jay from the studio for teaching and learning. We're starting class on time with a high quality recording that I'll be posting to Brightspace after class to support remote learning. And that's an example of, we had a tough problem there of how to get class started on time to support the previous instructor to get his video taped and uploaded, and for me to have a recording of this as well. And so that's a case where I had to look at what are my resources at the university, and Jay is sort of a resource, that your colleagues, the people you know, your friends, your parents are all resources, and he was able to help figure out the problem. So we did something that was adaptive in order to solve the problem, right? That's your adaptivity model. So today we'll talk about memory. Quick update, I have worked with the Brightspace folks to fix those grading errors for the week 1 and 2 quizzes. I do encourage you to make a habit of looking at feedback when it's available. Typically that's after everyone has written it, so not immediately after you submit it. Immediately after you submit it, you'll get your grade, so it's auto-graded, but then when the feedback's available, you want to take a look and make sure that there aren't any errors. There's human error, right? Anytime you get an exam and there's a grade back, you should ask to go and see it, because maybe the TA just marked something wrong and you can catch that. And then also, if there's valid errors on your part, you might want to know what those are. So you'll develop skills in, say, reading the questions, but you'll improve your understanding. So please let me know if anything comes up. And then today we'll talk about memory. What is memory? How does it work? And what parts of the brain does it use? Does anyone know what memory is? I see some knowing looks. We talked about learning last class. I think about how memory is related to or different from learning. So learning is the process of changing your knowledge or your behavior because of your experience. And then memory is like your persistence of that learning over time. Once you learn something, if it just kind of disappeared, it wouldn't be much good, would it? So the fact that learning actually changed your knowledge or your behavior means that a memory, whether it was a conscious one or an unconscious one, was formed. You know something more now, you're doing something differently now. You held on to that information somehow. Studying memory is like studying a mysterious black box. I can't kind of open your head, take out your memory, put it on a scale and say it's 3 grams and it's blue and it's 4 inches wide. I can't do that. It's in your head. I could see things going in. I could give you a sequence of numbers to remember. 5, 4, 7, 6, 3. And then I could ask you to repeat it. You might repeat that back to me. Maybe you do so correctly. Maybe there's an error, but something happened inside. And it's complex to study these things in psychology, because if we're studying things that you can't, well, we do measure them, but we don't measure them in the way that a physicist could measure something on a scale or look at a reaction test tube. So we can see that something goes into your memory. There's an input, okay? And then something happens inside. I can't really see what's going on, but I could make theories about what might be going on, and those theories could lead to predictions, and then we could do experiments to test those predictions. And over hundreds of years, scientists will elaborate models of memories. So a scientific model is a representation of a particular phenomena in the world. It's our idea of how we think it's structured and how we think it functions. So a model is a theory of what something is and how it works. It includes a mechanism for predicting psychological outcomes. And its point is to explain a specific psychological process. So we have a model of what memory is. We have a model of what learning is. Actually, there's more than one model because scientists might come up with different things. They might disagree with each other, and models can get elaborated over time. And we might argue about what's the best model. And we use these models, these conceptual models, to think and communicate about memory. So this is a physical model of the brain. And you get that the brain in your head doesn't actually have a green part or a blue part or a purple part. But the point of this, say blue part, is to point out, I think that's the sensory cortex. And this would be the motor cortex. And the fact that it's purple or blue helps you recognize the difference between them. You understand that there's a level of abstraction here, okay? And so this is a memory model. And we have an idea of how memory works. This is the Atkinson Triphen model, that information, so memory is your ability to hold on to this information, comes into your mind somewhere. And that would be sensory input. And right now, your sensory, there'd be sensory input from the floor to your feet, some sense of pressure. There's lots of things that your ears would be hearing now, whether you're aware of that or not. Somebody rustling something, somebody shifting around in their seat, my voice, something going on outside. And there's a lot of visual information coming in too. Like think of, all this visual information that's coming in. Me up here, the PowerPoint, what someone across from you is wearing, noticing somebody moving. Your senses are actually being bombarded at every moment. You're only aware of some of that though. So even though there's information coming to your sensory neurons about the pressure from the floor, because your feet are on the floor, you weren't aware of that until I mentioned it. You probably weren't aware of that. So some sensory information comes in, but it doesn't go up to your awareness. Now, there are a few things at a time that you can be aware of, that you can manipulate in your mind, do computations with. And your short-term memory refers to kind of the amount of those items that you can hold in your awareness. And, it's not 2,000 things at once. It's probably about 7 plus or minus 2 things at once. That's about as much as it can hold. It's temporary, it's short-term. And then working memory refers to your ability to manipulate it, right? To do computations with it. So short-term memory and working memory both get an idea of there's some sort of a short-term temporary store. And you can hold on for that for a while, maybe do something with it, and then it might leave your awareness, right? You might not form a long-term memory that you can access later. So maybe, I see this, whatever it is, these Lysol wipes. And so there's a representation of it in my mind, in my short-term memory. Let's say I look away and I never think of it again. I might not remember that those were ever on the desk. So getting into long-term memory is kind of a different issue. These slides do not want to turn. And that is because I did not stick that here. All right, so here's one way we can think of memory. And you'll recall that this is kind of cognitive revolution around the 50s when people started using computers. And so we can compare the human memory to a computer. You could say, all right, there are input devices, kind of like the keyboard where information goes into the machine. And maybe your ears are an input device. Information is coming into sensory information is coming into your mind from your ears and through your eyes and through your skin and your sense of touch. And then it's sort of held there. There's some kind of a processing unit. It's like your short-term memory and your long-term memory. And then you can sort of save files, let's say, to the hard drive. Those are like your long-term memories. And then there are output units. So if something is saved to your computer, you can bring it up again and it's, let's say, displayed on a monitor, or you can print it out again. And in memory, that would be your ability to recall, right? To pull up that memory and to recite it. There are limitations to that model. A computer uses sort of serial processing. It does one thing after another, but that's not how the human mind works. And if you go and save a file to your computer, it's saved to a specific location. That's not the way it works in your mind. It's kind of, it's saved in a distributed way, in a way that's about how neurons are kind of connected to each other. So that brings me to the Connectionist model, and that has the idea that there are units in your mind, and that unit would refer to a neuron, and they have connections with each other. And memories are seen as the product of an interconnected neural network. So a neural network is like a simplified model of the brain that's about how large numbers of these units, like this would be, which are the analogs of neurons, are connected together. And some connections are stronger and some connections are weaker. And we do know there's a process called long-term potentiation, that neurons that fire together wire together. So memories are something about the way neurons fire together. But this is all in the mysterious black box. That's why it's hard to understand. So there are 3 necessary stages for encoding, for forming memories. So it has to get in somehow. That's called encoding. I'm going to remember these wipes. I have to see them or feel them. And then that memory has to be stored. And once it's stored, it's no good to me if I can never access it again. I have to pull it out. That's retrieval. You can demonstrate that you remember something through recognition and recall. Recall refers to retrieving a memory, to sort of pull it out from your long-term memory and bring it into your conscious awareness. And that's a bit harder than recognition. So let's say that somebody asked me to recall what was on this desk, and I'm like, oh, I can't remember. I've seen so many desks all day. You know, there's something, maybe it was yellow. But now imagine if somebody showed me an array of 4 things, and one of them was this phone, or that was on the desk. 3 of them weren't on the desk, and one of them was this. You'd be like, oh yeah, that's it. I totally saw that. That is called recognition. So my question for you is, what do these test? Okay, so this is a fill in the blank. What is that testing? Yes, it tests your recall. And now this question. As Susie left for work, she said goodbye to her husband and slammed the door. The loud sound of the door made her husband flinch. After many mornings of hearing goodbye, followed by a door slam, her husband flinches when he hears her say goodbye. And in this scenario, hearing the word goodbye, which one is it? Yes.
Conditioned stimulus.
Perfect. Yeah. So it's kind of learned to be scared of the word goodbye. But I digress. That is correct, and I'm delighted. But what is this testing? Yes, it's testing recognition. So imagine, like, you might be on a test and you can't pull out the word conditioned stimulus, and maybe you're thinking of other C words. So it does help you out if the answer is there and you just have to recognize it. There's another way that we can demonstrate memory, that we have a memory. It's called relearning. If you go and learn something, let's say you learn how to figure skate, and then 20 years pass and you go on the ice with some friends who've never skated before, you're not going to skate like you did when you were 9, but you'll do it a lot more quickly and with more ease than somebody who's never learned before. So the fact that you could learn that thing more quickly demonstrates that you have a memory of it. So relearning, speed of relearning, is a measure of memory. Okay? So if you've learned to play the piano as a child, and then 30 years later, you want to learn to play the piano again, you will get along faster than somebody who's never touched a keyboard before. And that demonstrates that you have some memory of it. Hermann Ebbinghaus was a German psychologist who pioneered the experimental study of memory. And what he did is that he memorized nonsense syllables. He just like learned really long lists of things, and then he would see if he could recall them. And he found that the more times that he practiced this list of syllables, that he could relearn it faster the next day. He also found that if he learned something, he would be more likely to remember it accurately if he was asked to produce it really soon after learning it versus like a day after learning it. And so he produced something called the forgetting curve, which shows that once you learn something, it's easiest to remember it, immediately after, and then, half an hour later, an hour later, you're less and less likely to recall it. In 1968, Richard Atkinson and Richard Triphen presented a model of memory that we see here. It's known as the Atkinson-Triphen model, or the multi-store model of memory. And it's what we've talked about before. The information comes in from all directions. There's a representation of that in your mind that we're kind of holding on to very briefly. And maybe some of that will be encoded into your long-term memory. And this model assumes that there's no limit on long-term memory, that you can just keep putting things in there. So sensory memory is the first stage in forming memories. And it's like an immediate, very brief recording of sensory information in your memory system. And when we're talking about things that you see, that's iconic memory. And so your brain's recording of something you look at lasts for a very brief time before it fades away. And that is about like 1/4 of a second to 1/2 a second. And then maybe it's something that you remember. I will remember looking at this webcam. I'll go into my long-term memory. Or maybe you look away, you're not thinking about it again, and it just fades and disappears. Now, your echoic memory refers to things that you hear and lasts a lot longer. And I wonder if this has ever happened to you. Say that you're talking to your friend and your friend's telling you a story, or maybe it's a lecturer, the professor is lecturing and you're not listening. Maybe you're on your phone, maybe your head is somewhere else, and then your friend or your teacher kind of notices and they'll say, "What was I talking about? And what did I just say?" And you will be able to repeat back what they were saying, because 4 seconds is a long time. 1 Mississippi, 2 Mississippi, 3 Mississippi, 4 Mississippi. So you weren't listening, but they ask you that. You're able to access your echoic store. You actually have 4 seconds worth of what they were talking about in your information that you can access. And you say, "Oh, you were talking about," and then you refer to that, and they buy it, don't they? So you have to ask kind of a higher level question if you want to know whether someone was really listening to. Ask them about something that you said 10 seconds ago, because they can access the last 4 seconds in their echoic store. Short-term memory functions as a bottleneck to what you can ultimately remember, because you cannot be consciously aware of all the information that you're being bombarded with at any given moment. So right now, your senses are registering all kinds of things, the temperature in the room. There's so many things, right? And maybe you're focused on my voice, and that's what you're going to be remembering. Or maybe you're not, and you won't remember it, but that's why we have this tape. So it functions as a bottleneck because you can only be aware of such a small amount of it. This is referring to explicit memories, though. Right? There's implicit memory and unconscious memory as well. So this model has to get elaborated. So that came out in 1968, and other researchers have sort of continued to elaborate it since then. So the original concept of short-term memory got elaborated to add working memory. So short-term memory was just about what you can hold in your awareness at a certain time, but you're also actively processing and doing things with that information. And so working memory stresses the active processing you'd be doing. And one way to think of it is sort of like a temp file. Say you're sort of working on a document on your computer and it's a temp file. It's not going to get saved unless you actually do something to save it. So it might not go into your long-term memory. Then we also know that there is sort of unconscious learning and unconscious memory, and that would refer to, say, classical conditioning. You can do that to a sea slug. So this model has been updated to recognize that there's also automatic processing. We process and save information like outside of our conscious awareness. So the capacity for your short-term memory is quite limited, and there's been research on this. You might hear the famous magical number 7. Short-term memory can hold 7 items plus or minus 2. But that's based on a certain experiment where you're remembering a certain kind of thing. And then Badley and colleagues did some more research, and they found that people's sort of short-term stores could hold about 7 digits, 6 letters, 5 words. Maybe a word's a bit more complicated than a digit. Working memory is associated with intelligence, because intelligence, which we'll learn about next week, is your ability to learn from experience, solve problems, and use your knowledge adaptively. And when you're doing that, your working memory is going to be doing some computations. And its capacity varies by age. It's something that does, let's say, maybe peak as young adults and then reduce as we get older. So certain computational tasks would be more difficult for an 80-year-old. It might be slower, make more errors than for a 20-year-old. So I hope this works. What would happen if short-term memories never went into long-term memory? Say something was broken in this system. Someone had some kind of accident. And the short term, the information came through the sensory register, went into short-term memory, and that stops right there. There's a famous patient in psychology who's known as HM for the longest time until he passed away, and then his real name came out. Sorry, I didn't write it there, but it's Henry Molaison, so known as HM. And here's what he taught us about memory.
On September 1st, 1953, William Scoville used a hand crank and a cheap drill saw to bore into a young man's skull, cutting away vital pieces of his brain and sucking them out through a metal tube. But this wasn't a scene from a horror film or a gruesome police report. Dr. Scoville was one of the most renowned neurosurgeons of his time, and the young man was Henry Molaison, the famous patient known as HM, whose case provided amazing insights into how our brains work. As a boy, Henry had cracked his skull in an accident and soon began having seizures, blacking out, and losing control of bodily functions. After enduring years of frequent episodes and even dropping out of high school, the desperate young man had turned to Dr. Scoville, a daredevil known for risky surgeries. Partial lobotomies had been used for decades to treat mental patients, based on the notion that mental functions were strictly localized to corresponding brain areas. Having successfully used them to reduce seizures in psychotics, Scoville decided to remove HM's hippocampus, a part of the limbic system that was associated with emotion, but whose function was unknown. At first glance, the operation had succeeded. HM's seizures virtually disappeared, with no change in personality, and his IQ even improved. But there was one problem. His memory was shot. Besides losing most of his memories from the previous decade, HM was unable to form new ones, forgetting what day it was, repeating comments, and even eating multiple meals in a row. When Scoville informed another expert, Wilder Penfield, of the results, he sent a PhD student named Brenda Milner to study HM at his parents' home, where he now spent his days doing odd chores and watching classic movies for the first time, over and over. What she discovered through a series of tests and interviews didn't just contribute greatly to the study of memory, it redefined what memory even meant. One of Milner's findings shed light on the obvious fact that although HM couldn't form new memories, he still retained information long enough from moment to moment to finish a sentence or find the bathroom. When Milner gave him a random number, he managed to remember it for 15 minutes by repeating it to himself constantly. But only 5 minutes later, he forgot the test had even taken place. Neuroscientists had thought of memory as monolithic, all of it essentially the same and stored throughout the brain. Milner's results were not only the first clue for the now familiar distinction between short-term and long-term memory, but showed that each uses different brain regions. We now know that memory formation involves several steps. After immediate sensory data is temporarily transcribed by neurons in the cortex, it travels to the hippocampus, where special proteins work to strengthen the cortical synaptic connections. If the experience was strong enough, or we recall it periodically in the first few days, the hippocampus then transfers the memory back to the cortex for permanent storage. HM's mind could form the initial impressions, but without a hippocampus to perform this memory consolidation, they eroded like messages scrawled in sand. But this was not the only memory distinction Milner found. In a now famous experiment, she asked HM to trace a third star in the narrow space between the outlines of two concentric ones, while he could only see his paper and pencil through a mirror. Like anyone else performing such an awkward task for the first time, he did horribly. But surprisingly, he improved over repeated trials, even though he had no memory of previous attempts. His unconscious motor centers remembered what the conscious mind had forgotten. What Milner had discovered was that the declarative memory of names, dates, and facts is different from the procedural memory of riding a bicycle or signing your name. And we now know that procedural memory relies more on the basal ganglia and cerebellum, structures that were intact in HM's brain. This distinction between knowing that and knowing how has underpinned all memory research since. HM died at the age of 82 after a mostly peaceful life in a nursing home. Over the years, he had been examined by more than 100 neuroscientists, making his the most studied mind in history. Upon his death, his brain was preserved and scanned before being cut into over 2,000 individual slices and photographed to form a digital map down to the level of individual neurons, all in a live broadcast watched by 400,000 people. Though HM spent most of his life forgetting things, he and his contributions to our understanding of memory will be remembered for generations to come.
So if HM, if you were one of the people that worked with him, if you came in to the room and introduced yourself and got to know him a little bit, and then you walked out of the room, to him, you'd be walking back into that room as a new person. You just have no memory of what just happened. He did remember his life before the operation. There was a bit of loss of memory from right before, but he would know who he was and about his own life history. But what that meant is that when he looked in the mirror and he was, not a young man anymore, that would be shocking to him. Okay. And he had a special relationship with his uncle, and he would ask people, how's his uncle doing? And they didn't lie to him, but at some point they had to say, your uncle passed away. And he's like, he's hearing that for the first time again. It couldn't form long-term memories. So what we learned from that case is that there is a system for explicit conscious memory, and then there's also unconscious memory. So you are storing and processing, and you'll be able to remember some information without ever having tried to, without ever having been knowingly aware of having learned it. So we've been talking about the kind of explicit memory system with the Atkinson Triphen model. And so there's a role for processing that in the hippocampus and the frontal lobes. We'll come back to that. Those are different parts of the brain. But your explicit memories are divided into your semantic memory and your episodic memory. So you have a memory for facts and for general knowledge. So everything that you know about psychology, everything you've learned about learning, about memory, about motivation is now part of your semantic memory. Your knowledge of English, right? All those general facts, that's your semantic memory. But then you also have memory for your life. Like you may remember this lecture because you were here watching it, and that refers to your episodic memory. Your memory of your 5th birthday. That's an episodic memory. Think of it like watching an episode of something. So that's the effortful explicit side. These are sort of declarative memories that you could tell me about. Say, yes, I know the definition of learning, and pull that out of your semantic memory. Or you could tell me about your 5th birthday party that you remember from your episodic memory. But then there's also sort of unconscious memory. There's also an automatic process, and those are called non-declarative memory. And they come up for you without conscious recall, and you might not be able to tell me about them. Now, somebody like HM wouldn't be able to tell you where the bathroom was on his hospital ward. Let's say if you asked him. He wouldn't know. But he might be able to need to go to the bathroom and get up and just find it somehow. And those memories are processed in a different part of the brain, the cerebellum and basal ganglia, and those parts of the brains weren't hurt by HM surgery. And this includes sort of space, time, and frequency. So you did not go through your day-to-day with a sort of logbook saying, okay, it's 8 a.m., I got up, and then I went to the washroom, and then I brushed my teeth, and then I went to the kitchen and I poured my cereal. You weren't trying to sort of encode or remember that, but it is encoded. And if I asked you what you did today, you'd be able to tell me that you did X and Y and Z, and you went there and you did that. Okay. Then you have a memory of how to skate or how to ride a bike. So your motor and your cognitive skills are also part of your implicit memory. I'm going to jump back to the spatial stuff. If sometimes students who are new to the university get really worried about how they're going to find their way from the Loyola building to McNally, Maine, and how are you going to remember and learn all that? Don't worry about it. Don't stress. Just wander around, explore the building, right? Don't try to remember any of it. And you will learn that, and you will find yourself kind of able to find your way to your next class with much more ease than you might expect. Okay, then there's classical conditioning. Operant conditioning is a bit more explicit, or would involve an episodic memory. I touched this lever, then I got a foot shock, damn, I won't do that again. But classical conditioning can be implicit. So let's say you go to your dentist's office and you feel stressed, because your body knows that pain is associated with being there, right? And we can classically condition sea slugs because these brain regions are simpler and less complex than frontal lobes are a big deal. Okay, that's a later evolutionary development. Sometimes you might be aware of, might have a gut feeling. you're somewhere and you're just like, I don't like the feel of that place. Your gut feelings refer to your implicit memories. Maybe you were in a place like that before, and something bad happened to you, and now you're in a place like that again, and you're like, I don't like this. With experience and practice, explicit memories can become automatic. When you first learn to drive, at your first time in your car, you're probably very aware of, this is the steering wheel, and I put my foot on this, and right, that was happening at the explicit level. But now you've done that so many times that it may have become automatic. At first, you're like, left turn, what? How do I do that? And how am I gonna complete the turn before that car comes and hits me? But you were there once. But now maybe you can drive somewhere and end up somewhere and not remember having driven there, because it's become an automatic memory. Let's talk about some of the brain regions. So your explicit memory system involves the hippocampus and frontal lobes. The hippocampus registers and temporarily holds parts of explicit memories before moving them to other brain regions for long-term storage. I like to think of it as like a library shelving assistant. Those people who like push around the book trucks. They sort of collect the books that have been left around, and then they pick them up and they look at the code on it and have to go and put it back in the right place. So your hippocampus is your brain's library shelving assistant, book truck clerk. Memory consolidation refers to that process of storing long-term memories. Sleep is really important for that. It's one of the things that happens while you're sleeping. So if you do some studying and then go to sleep, you would remember that better than if you sort of stayed up late, even though you weren't studying anything while you were sleeping. You're letting your library shelving assistant work in your mind. Now, none of you should have memories from the first 3 years of your life. It's called infantile amnesia. If you have a memory of it, it may very well be a false memory, unless there's something very special about your brain. And that is because, for two reasons. One of them is because the hippocampus hasn't developed sufficiently by that point. And then another one is that a lot of our explicit memories, our declarative memories, are based on language. And a child's language abilities aren't developed by that point. However, there certainly is implicit learning, and babies can be conditioned and can hold on to those responses. The implicit memory system involves your cerebellum and basal ganglia. The cerebellum is quite involved in movement and balancing, and it looks like a little brain at the back of the brain. And it does play an important role in storing the memories that are created by classical conditioning. So your memories of a physical skill, if you're pulling up your ability to skate when you go on the ice, refers to implicit memory as well. Yes?
How does like a photographic memory work?
Like a flashbulb memory?
Yeah.
Those can happen, and they are associated with stressful events. Like, let's say you're in an accident and you have a memory that is like a picture of in front. And that's associated with a different part of the brain called the amygdala. Actually, I think we're getting there next. So if you are emotionally aroused, let's say you're really angry or you're really stressed, there's going to be a flood of hormones, and those hormones enhance the activity in certain memory forming areas that are associated with emotions, and the amygdala is one of those. So the amygdala is involved in the storage of memories when something exciting or stressful is happening. And there's exactly what you're asking about, flashbulb memories. So those involve the amygdala. It's a midbrain structure that looks like an almond. Amygdala is Latin for almond. When neurons fire together, they wire together. And your memories are formed by those connections. And that is the neural basis for learning and memory. So learning something results in some kind of activity in your brain cells. There's some, say, release of neurotransmitters. And you can develop, sort of say, more synapses, or you can, your brain can learn to put out more neurotransmitter in response to something. But this is going back to the idea of connectionism. So your memory is about the way brain cells fire together. It's about connections and patterns. Okay, so a really important strategy if you're trying to remember something is rehearsal. It's like deliberately practicing it. So if I ask you, let's say I present you with the numbers 4, 7, 12, 9, and I don't let you think about it or say those numbers, you're going to be less likely to remember them 5 minutes later than if you've been rehearsing those numbers to yourself over and over and over again. Because that's developing that pathway, that connection, right? Those neurons, they're firing together and wiring together. Now you're going to leave a stronger trace. So rehearsal is really important for memory. And I'm sure you find yourself rehearsing when you're studying. Memory consolidation, though, is a process. And that works better when you do it over time rather than, let's say, all at once under a lot of stress. So distributed practice, let's say you want to learn that little sequence of numbers I gave you, you'd probably be best able to retrieve it for me later if you, okay, so sure, let's say if you practice it 100 times, it'd be better if you distributed that practice. Maybe you spent an hour every day doing that, and then you had a good night of sleep. Going to form a better memory trace than, let's say, you took those 100 trials and you did them all at once right before I was going to ask you to perform that. I want to relate this to your study habits. If you sort of study, let's say for this class, in order to perform well on your quiz, it's much better that you distribute your practice. So let's say there's going to be about 10 hours a week of studying. Doing that all at once on a Saturday, even if it's kind of the same amount of time, isn't going to have the same effect on your performance than if you had developed stronger traces by distributing that practice, doing it in short chunks, letting your mind and your brain recover, sleeping on it. Same 10 hours, right? You're going to get a better effect on performance if you spread them out, right, 1 or 2 hours a day, than if you do it all at once and cram. There's another strategy called chunking. So we know that you can hold about, let's say, 7-ish things in your short-term memory at a time, but it doesn't really say how big is that thing. So if I give you the number sequence 902414451, it's easier to remember it like that. And that uses the strategy of chunking. So I didn't count them, but let's say that's something like, 10 items. Well, now you've turned it into sort of 3 items by chunking. So that's a good memory strategy, and we do it with phone numbers all the time. A strategy that helps you remember something is called a mnemonic device. And acronyms are one of them. So ADHD means something. It means attention deficit hyperactivity disorder. And let's say I was trying to memorize that term. Learning that ADHD could help me pull that up later. IQ means intelligence quotient. And these little chunks might be easier to learn, and then they function as some kind of a prime for you to remember the whole term. Another strategy is called an acrostic, and that's when the acronym represents a sentence. When I worked in the College of Pharmacy, the students there, well, they're very kind of like buttoned up and professional because it's a professional school, and then people will like kind of would dress for tutorials and they'd be on their best behavior. So you can imagine my shock when once in the middle of a tutorial, a young lady said something that was, it was really shocking. It was very sexual. And she said it with a straight face. And I remember it was the first time I ever heard anything like that. And I thought, what just happened? And what is my responsibility now? And should I report this? And then immediately after, another young lady on the other side of the table said something that was like even worse. What the hell's going on? And nobody looked shocked. Everyone was sort of like listening and taking notes. And what was going on there? So medical students, pharmacy students take advantage of a lot of memory strategies to learn difficult things. And so the one I have there, scared lovers try positions they can't handle, is the one that I can put up on a slide, but mostly they're way more shocking like this. I could not put them up on a lecture slide. You can see the strategy here. So they're learning the like the trigeminal nerves. They have to be able to write these on an exam. And so they learn these shocking acrostics. And so I guess you can see the strategy there. So scared relates to scaphoid. I probably should have highlighted this first three, right? Lover is his lunate. Try is triquetrum. You see a strategy. Okay. And one of the reasons that they are so inappropriate is that we're more likely to remember things that have an emotional component. So that's also strategic. Hierarchies help us remember things. So if you're trying to learn all this information, it helps you remember it, that it's in this nice little diagram there, right? That there's automatic and effortful or unconscious and conscious memory, and then these conscious memory breaks down into semantic and episodic. This organization is something that helps you remember, versus if it was all written down in, say, a paragraph. The spacing effect is what we're kind of talking about with cramming. Encoding, so encoding the memory, that's the process of putting it into long-term memory, is more effective when it's spread out over time. Mass practice, trying to learn everything all at once, well, it's a way to do things quickly, and it'll give you some short-term learning, but you're more likely to forget it. So if you have an academic strategy of cramming for a midterm or a final, you probably, or you're less likely to remember that information from the course, say, a year later, than if you had a strategy of spacing. And research has shown that students tend to forget what they learned in a course quite quickly after the end of the course. So there's a testing effect. So if you're trying to learn something, if you test yourself on it, you're more likely to remember it. And people use flashcards to do that, right? You show yourself a word, say, okay, what's the definition of that word? You're testing yourself, and maybe you get it right. You flip over the card to see what the definition is. Maybe you got it wrong. Do that a few times, and you're going to be more likely to produce that definition on a test. Last year, I gave students practice tests before the quiz. So they usually something like 5 modules before a test, let's say 6, and that would mean they'd get 5 or 6 practice tests before the weekly test. The correlation between whether or not they did those tests and their weekly test grade was 0.9. That's astonishingly high. So 0.9 times 0.9 is 0.81. Whether or not they did those practice tests explained 81% of their variance in their average weekly test score. The correlation between how much time I spent studying, which I tracked because it was one of those courses with the access code in the ebook, I'm not doing that this year, but I did track it then. The correlation between time they spent in the ebook doing practice tests and their final test rates, 0.3. 0.3 times 0.3 is 0.09. Time spent studying and reading predicted 9% of the variance in their average weekly test score. That practice testing worked a lot. So I'm not requiring that this year, but if you want to do that, you can, because there are practice tests in your textbook you can access. And then if you got Launchpad, it will give you the option to do these adaptive learning assignments. It helps if you process information more deeply. So let's say I ask you to remember 3 numbers, 472. If you came up with some kind of a story, like what is the meaning of 4 to you? Right? You only have 4 fingers on your right hand. And what is the meaning of 7? It was your lucky number on a certain day in your life. If you sort of try to connect it to more things, process it more deeply, you're going to be more likely to pull it up later. So shallow processing encodes information on a really basic level, just like the word, its letters, how it sounds. But now you try to connect it to meaning, especially personal meaning, you're more likely to remember it. So your memory is about connections. The more connections you make and the deeper you can make them run, the more likely you are to store that memory and pull it up later. Now, I have a question for you. Okay? I want you to answer as a group as fast as you can. What color are clouds? What color is snow? What do cows drink? No, they drink water. What happened there? I can't hear you. Why did you all say milk when obviously you know that cows drink water?
Cows produce milk and milk's white.
Because of all those connections, right? So I asked you a bunch of questions about clouds. Yes, exactly what you said there. And those connections are priming this idea of milk. They all connect somehow to milk. And I primed it 3 times with those questions and once again with the visual prime of actually seeing milk. And that is why you said milk, even though you know better. So that is a demonstration of what a prime is. So if 2 things are connected and you activate some connected idea, you're going to be more likely to remember that other thing that's associated with it. Context matters. I say that a lot. It also matters to memory. If you are drunk and you lose your keys and you can't find them later, you might find them if you get drunk again. Because your memory of where you put the keys is associated with being drunk. So being drunk again might help you access that memory. You are more likely to do well on a test if the test is administered in the same room. I'd expect the class average on a test or an exam to be lower if I gave it the test in, those, I don't know, those exam spaces at Dell. They used to do it in like gym, they fill the gym with desks. Then if you wrote it in here, like where, let's say, you lectured or you studied. And sometimes you can just like wander into these rooms and use them when they're empty. Take advantage of that. Your tests are online, so you get to choose where and when you do those. But if you can keep it consistent, where you study and where you were tested, you're more likely to have better performance on the test because some of that learning is associated with context. Or in the same context, you're going to pull up those memories easier. That explains why certain situations can be triggering for people. And if somebody has a traumatic experience, now they are back in a place that reminds them when that happens, like a trigger. Then there's the serial position effect. You're more likely to remember that, let's say if I presented you an array of letters or numbers, to remember the first few or the last few. And there could be reasons for that. Right? Maybe you remember the last few because they're still in your echoic store. But there is an effect where, let's say you're meeting a bunch of people, you're more likely to remember the first ones or the last ones. As we've talked about before, you're more likely to remember something if you can relate it somehow to yourself and your own personal stories or experiences. And most people excel at remembering things about themselves. And there's actually, that's a stronger effect in individualistic Western cultures, right? Members of more collectivistic cultures can also remember things well if they're made relevant to their family. I'll talk about forgetting. Not necessarily a bad thing. Forgetting can be adaptive. If you want to know what your friend's phone number is, maybe it's a good thing that you can't remember their last 5 phone numbers. We are only going to remember a small amount of all the information that comes into us, and then we might have some trouble retrieving it. That's kind of what forgetting is. The Atkinson-Triphen memory model doesn't put any cap or any limit on how much you can remember. Right? In that model, according to the model, it has an infinite capacity, and your problem is pulling it out again. And as a theory, maybe you could come up with some ways to test that theory to see if it's true, but that is the theory. There are a lot of things that affect our ability to remember something. You know, was there a recall cue? You know, kind of, are you in the same kind of mood than when you encoded it? Okay, so some things just don't get retrieved. And I'm sure you've been in that position on a test where you're like, I know the answer to this, and you just can't produce it. Rehearsal matters a lot. If you want to remember something that you learned in class, you're best off sort of rehearsing it right after class. So let's say there's 15 minutes after class. These are usually about half an hour before the next class comes in. If you were to just like look over your notes then and there, you're more likely to remember it than if you did that little review 2 or 3 days later, because of the way that memories decay. Have your best bang for your buck if you did that right at the end of class when it was still fresh. The phrase "we remember more than we recall" gets at that idea that it's hard to pull things out of the attic. So you have all kinds of memories in there, and whether or not you're able to pull them out, access them when you need to be able to do that, it's a different matter. You may have heard of Deja Vu before. It's that sort of creepy feeling that this has happened before. Yeah, so that's another context point. So when, let's say that you've been in a classroom just like this before. So maybe you're watching me now thinking like, I've done this before, but you haven't. You've been in a classroom like this, maybe with a different instructor. So cues from the current situation can unconsciously trigger retrieval of an earlier experience that didn't actually happen, but that's what's going on with Deja Vu. There are lots of different reasons why we forget things. One of them is that maybe you never encoded it in the first place. Maybe you didn't go from short-term memory to long-term memory. That'd be an encoding failure. Encoding gets a bit harder as we age. Sometimes it doesn't happen at all if you're not paying attention. So if you go to lectures and you're thinking about something else, well, you're not going to remember because you didn't encode it. And then there may be decay and storage that's associated with kind of physical decline in the memory trace. So if your memory trace is about the connection between neurons, well, what happens if one of those neurons die? And as you get older, brain cells do die. I think you lose something like 25% of the volume in your hippocampus by the time you're 80. And then there's brain damage. Look what happened to HM when they took out his hippocampus. Right? He lost the ability to form new memories. And he lost some of his more recent memories before the procedure. So you could harm a brain in a way that memories are lost. So HM had something called anterograde amnesia. He could remember his past, but he couldn't form new memories. So his amnesia, or for his forgetting, was for everything that happened after the surgery. He could hold it in his short-term memory, but he couldn't put it into his long-term memory. Then there's retrograde amnesia. People with Alzheimer's disease come to forget their past, right? They can't remember who their family members are. So retrograde amnesia is about forgetting your past. Someone with retrograde amnesia might forget whether they own a car, what type it is, when they bought it, but they can still remember how to drive. How could that happen?
That's like other functions or different memories. Like thinking like riding a bicycle, you don't. It's just like your body knows how to do it subconsciously.
Exactly. It's the different track. It's that implicit track. So your ability to drive is an implicit memory, and those other things like whether you own a car and what type of car it is and what the license plate numbers are getting at your explicit memory, your sort of semantic knowledge of the facts about your car and maybe memories of the fact that you've driven it in the past, right? We're talking about different tracks. So you're exactly right. That is what explains why someone could forget whether they have a car and what they did and what they ever did with it, but still get in a car and be able to drive it. Then there's interference. Sometimes things can mess us up, and there's proactive interference and retroactive interference. These can be a little bit tricky. So proactive. And what was the other one? Retroactive interference. And the way I remember them is by kind of what is getting disrupted. And so proactive interference is reduction in memory performance for recently learned information, for new information, from old information interfering. So the old information is messing up the new learning, the new information. So an example of that is if you're writing in your notes that it is January 2021. It's not, it's 2022 and you know it, but all your old learning of 2021 is interfering with the new stuff. So it's proactive because the old stuff is interfering with the new learning. And then retroactive interference is when new information interferes with the old information. You've learned to play a new song, and now you're getting messed up when you're trying to play the old song. Start playing the new song. You have learned French at school, and now here you are at university learning Spanish for the first time. You go back and try to speak French to somebody, and you're starting doing Spanish conjugations. New learning is disrupting the old memories. Motivated forgetting is the idea that sometimes we might forget because we want to forget something. You're like, I don't care, I don't want to think about that, not gonna remember that. it's important to also know that memories aren't just like accessing some file that you saved and there it is, just like the time that after you encoded it, and it's like that forever. There's an element of construction to memory. And Elizabeth Loftus demonstrated this experimentally. She was a forensic psychologist. So you have people watch video footage of car accident. If you ask them a neutral question, so how far, how fast were the cars going when they collided with each other? Like collided, maybe that's pretty neutral. And they'll give you some estimate, 50 kilometers an hour, and that's your baseline. Well, now, if you change the question, you say, how fast were the cars going when they bumped into each other? They're going to remember the cars as going slower. Now, if you ask them, how fast were the cars going when they smashed into each other? Well, now people remember they're going a lot faster. And now they can also remember broken glass. It wasn't there. And that's because the word smash is a prime for these associations, right, for a broken glass going really fast. Now your memory of seeing the video has changed. And that's called the misinformation effect. There's ways of asking people questions that were really misleading. Let's say that the suspect was not wearing a jacket. Someone asks you, and what color was the jacket the suspect was wearing? I think it was, let's say they're wearing a black t-shirt. I think it was black. And now the suspect is wearing a black jacket, but there was no jacket there before. If you repeatedly imagine something that didn't happen, a fantasy, whether it's one of your own or one that someone else suggested, that can create a false memory that it actually happened. Sometimes we remember things as they didn't happen because we're like mixing together multiple memories. So let's say you're working the till at the store and a customer comes in and they buy some chips and they're wearing a green ball cap. And now the bank robber comes in and he has no hat, but you're asked for a description of the bank robber, or sorry, of this convenience store robber, and you remember somebody with a green cap because that's what the person before was wearing, kind of mixing them up. So that brings me to reconsolidation. And in a computer analogy, let's say you write a document and you save it and you open it again. 5 minutes later, 10 minutes later, a year later, it's the exact same document. And say you don't change anything and put it away, 20 years later, pull it up again, it's the same thing. When we access our memories, it's like we look at the file again and maybe we make some edits. Maybe you think about this part. Maybe you start remembering something else that happened to someone else. It's like you edit the file and then you save it again. And every time you open it, you're doing something with it and then reconsolidating it. This is why people's memories change over time. People are very suggestible, generally, right? People can be asked misleading questions and start remembering jackets and hats that weren't there before. If somebody is being asked a question by somebody with status, and if the person with status is suggesting that they want to hear a certain answer, people might produce that answer. And maybe they really believe it. People will kind of do things like that. Sometimes, I'm sure it's happened to you that you're telling someone a story about what happened, and maybe you exaggerate it a bit for dramatic effect. Well, your memory of the real event could start to change based on that. Maybe you really believe that something much more dramatic happened. So your memories aren't kind of like a stable, unchanging thing. And you could argue that what we really remember is a coherent narrative. and that story can get built and can change over time. Yes.
How does like PTSD work?
Sorry?
How does PTSD work?
Ooh, PTSD is a disorder. It's a sort of a stress disorder. And when something happens to somebody that can be life-threatening, there's going to be a lot of stress hormones involved in that. And so you have like flashbulb memories. You could have triggers where you're in an environment that's sort of similar, reminds you of it, and sort of puts you back into that fearful state. People don't feel really safe. They're hyper-vigilant of things that can happen. So it's like a stress disorder, and it's something that happens to people who have had life-threatening experiences. Now I know that there's psychologists' definitions and labels of disorders change, and there is some question about whether you can have something like PTSD to, let's say, I don't know, just social traumas, because people who, let's say, who have been bullied might have something that kind of looks like PTSD, but technically it can't be PTSD because it wasn't life-threatening. So there are these sort of debates between psychologists, but basically it's a stress disorder. So if some very stressful things happen to you, that's going to affect your memory. Sorry. Oh, right. So false memories. The Twin Tower, the terrorist events of 9/11, of September 11th, in the United States, are an example of false memories. Sorry, I'm kind of losing my train of thought. There are a lot of people who report having seen footage of the first plane hitting the buildings. They'll be able to say, I was at work and I was when I looked at the TV and I saw the footage of the first plane hitting the buildings, and I was doing this and my boss said that, and then we had a meeting, and then we saw the footage of the second, but people believe that. There's no footage of the first plane hitting towers. So false memories are common, and they don't really mean that that people are trying to lie. They are sort of a phenomenon. So what we often remember in terms of episodic memory is a coherent story. And that story has an element that's constructive, that's subjective, that's built over time. It depends on what other people say that they can remember it. And they're sort of subject to modification. Ooh, we're almost at time. Juries tend to be easily impressed by eyewitnesses. Well, there's a witness. They said they saw it happen, so that must be true. And judges are impressed by what juries think. Eyewitnesses can be reporting memories in good faith, but those memories aren't necessarily a reliable record of actual events. Could have been asked leading questions by police. They could be mixing up 2 or 3 real memories into a new memory that could be real, and that can have implications for people's lives. Somebody might be effectively falsely accused or investigating what they didn't do. And I've seen people go through that in the basket case that they can be as a consequence. Brings me to repressed memories. So we can ask this question like, do people remember or forget traumatic experiences? It's kind of both. There is evidence that people can vividly remember traumatic experiences, right? Especially people with PTSD. Well, there's also evidence that there's something called dissociative amnesia. People can completely forget about something traumatic. It's when somebody forgets details, personal information that's associated with a traumatic event. So we can say the brains are complicated. And this can be sort of controversial for social or political reasons, like who do you believe and when do you believe? And those are different questions. Eyewitness recall with children. It's also, we have to be aware of suggestibility then there as well. So there was a study by Stussy and Bruck that showed an effect of suggestive interviewing techniques. And in that study, doctors examined a child physically. This was all experimental, it was observed. And so they knew what the doctor was doing. But then when asked kind of suggestive questions later, shown a sort of anatomical doll, like where does the doctor touch you? Right, 58% of the kids would say something that didn't happen. Like, the doctor touched me between the legs. And that's an effect of what the way the researcher is asking the question. So ethics are important. it is possible for children to accurately recall events and actors, but that's done by somebody trained and who uses objective methods, right? Ask non-leading questions soon after the event, using words that they can understand. So what do we know from psychological research? That abuse does happen, but that also injustice happens, right? There are false memories. People are falsely accused. That forgetting happens. You can recover memories, right? That people can vividly remember things or kind of dissociate and forget. But we do know that if it's under the age of 3, if the therapist hypnotized you, then it may well be a false memory. But it's important to consider that memories, whether they're real or false, can cause distrust for people. Certain schools of thought in psychology, let's say in counseling, would say it's not the therapist's place to judge whether memory is real or not. And I'm going to read this because it's from a handbook on counseling. Early recollections, anecdotes, and memories may not be literally true, but this doesn't minimize their personal significance. Rather, they function to symbolically indicate whether people need to know about themselves, provide a sense of comfort, security, consolation, or source of advice from within regarding how to navigate transitions. That psychologist is not at all concerned with whether the client's memories are true or not. So in certain traditions, you're asking, okay, how's that story working for you? Is it helping you live the life you want to lead? That is a completely different job than a forensic psychologist, right? If you're using those memories as evidence where, let's say, somebody might get fired or somebody might go to jail, a very different context, very different role for a psychologist and the approach they might use. So forensic psychologists would do things like consider whether evidence is reliable, would interview children, for instance, and do psychology with the prison population. I ran a minute over time. Thanks for your patience. For next class, please read the modules on intelligence, and your quiz is due Sunday at 5. And please reach out to me if you have any questions.